correct IUPAC name for the following compound is. And so whenever we're looking for an IUPAC name, that is the systematic name. And so in our systematic nomenclature, we want to find the longest carbon chain that contains the principal functional group. So the functional group we have here is a carboxylic acid. So we want the longest carbon chain that contains that carboxylic acid. And we often also want to start numbering at that carboxylic acid. So that is going to be carbon number 1. Which we would know that that's carbon number 1 to carboxylic acid. So we won't include that in the name, but that is where we start numbering our chain in order to see where our substituents might be located. So 1, 2, 3, 4. And here we get to a branch point. So whenever you look at a branch point, you go in the direction that's going to give you the longer chain. So we're going to continue up this way. So 5 and 6. So we have a methyl group off of carbon 4. So this is 4-methyl. And this is a hexane chain. And so we are going to, so it starts with hexane. You drop the E and you add to that oic acid. So this is hexanoic acid. So we have 4-methyl hexanoic acid. And then the final detail that we want to fit in is that we have a chiral center. So we need to specify whether or not that chiral center is R or S. And so we can see right now the 3 groups that are attached to that carbon. What is not being explicitly shown is the hydrogen that would make up the 4th bond. So we need to know where that is. And this is a tetrahedral carbon. We see 2 bonds in the plane. We see 1 sticking out of the plane. That tells us that our hydrogen is going back into the plane. And then when we assign a chiral center, we want to make sure that the lowest priority group is oriented facing away from us. So this is actually a very convenient example because hydrogen, having the atomic number 1, would be the lowest priority here because we go by atomic numbers. That's priority group number 4, and that's already sticking in the back. And then we need to compare the other groups attached to that chiral carbon. And so if we go through atom by atom until we find a point of difference, and we're always deciding by atomic number, we will find out that this is our highest priority group, followed by here, and then finally the methyl group. And then what we do to assign R and S is we're going to draw the arc. Once that lowest priority group is oriented away from you, and we were lucky it came that way, we didn't have to redraw it. We're going to draw an arc from 1 to 2 to 3 and see what direction that's going. And since this is counterclockwise, that means that chiral center is S. So this is S, 4-methyl hexanoic acid, which is the option A. And so if you need a refresher on R and S, that is back in chapter 4, and you have that chapter 4 study guide available to you to go back and review.